Space is an ocean of silence. Here, distances are not measured in kilometers, but in light years. Here, tomorrow doesn't mean the next day, but the next million years. Into this infinite darkness, we have sent a small thing. Friends, an 800-kilogram machine made of aluminum, copper, and gold. Hello, friends. Today, we're going to talk about something that is not just a science mission, but humanity's greatest hope and greatest risk. We are talking about the Voyager spacecraft. For the past 47 years, it has been continuously moving away from Earth. Friends, this is the farthest traveling man-made object ever created. Currently, it is 24 billion kilometers away from us. If you started traveling at the speed of light right now, it would still take you 22 hours to reach it. But the purpose of this video is not to find out where Voyager is. Rather, the purpose of this video is to ask a chilling question. Will they be able to find it? They meaning aliens, extraterrestrial intelligence, hidden inside Voyager is a message. A map that points directly toward Earth. Scientists have calculated that Voyager will survive in the universe for the next billions of years. So today we will use data, math, and physics to analyze what the mathematical odds are of Voyager being found. Did we make a mistake by giving away our address? And if some alien finds it, how will they understand this 1970s technology? Fasten your seatbelts because this journey is going to be very exciting. The story of Voyager doesn't begin with aliens. It starts with a mathematical miracle. In 1960, a NASA intern named Gary Flandreau noticed something strange. He observed that in the late 1970s, Jupiter, Saturn, Uranus, and Neptune, these four giant planets were going to align in a perfect line. Such an alignment doesn't happen every year. This alignment happens once every 176 years. This meant gravity assist. Normally, traveling from one planet to another requires a lot of fuel. But if the planets are in a line, you can use one planet's gravity to slingshot to the next planet for free. NASA had only one chance. If they didn't launch in 1977, the next opportunity would come after 176 years. That's why mission Voyager was approved. Friends, remember this was 1977. Voyager's computers had only 69 kilobits of memory. Yes, I'm talking about kilobytes. In the time it takes you to upload a high-quality Instagram photo, they ran an entire spaceship with that much memory. They built 2 spaceships. Voyager 1 and Voyager 2 went on different paths, but both had the same purpose. First, to explore the planets and then to disappear forever. Friends, before understanding the grand tour, let's learn something about the golden record. When it was decided that Voyager would leave the solar system, scientist Carl Sagan thought, why not put some message in it? Maybe millions of years later, someone will find it. He created the golden record. This is not an ordinary record that plays on old gramophones. It is made of copper and coated with a layer of gold. But why? So that it doesn't get damaged by space radiation and dust. Friends, you will be surprised to know that its shelf life is 1 billion years. But think about it. If some alien finds it, how will they know how to play it? They won't have a turntable. That's why the instructions are engraved on the record's cover. These instructions are not in any language, because aliens don't know Hindi or English. These instructions are in the language of science and math. What is in this record? This record contains 115 photographs showing our life. It has many types of sounds. Rain, storm, and train, and even the sound of a mother kissing her child. And most interestingly, greetings in 55 languages. Friends, this is not just data. This is our soul. We didn't show aliens how powerful we are. Rather, we showed how emotional we are. This was humanity's attempt to reach out across the cosmic void to say that we exist, we feel, we love, we hope. Every sound, every image was carefully chosen to represent the diversity and beauty of life on Earth. There are sounds of laughter, sounds of music from different cultures, sounds of nature. There are images of families, of cities, of landscapes, of DNA structures, of mathematical equations. The golden record is essentially a time capsule, a message in a bottle thrown into the cosmic ocean, carrying with it the essence of what it means to be human, the selection process for what went on to. The golden record was incredibly thoughtful and deliberate. Carl Sagan and his team spent months deliberating over what should represent humanity. They wanted to show our scientific achievements, but also our capacity for art, for emotion, for connection. They included images of a man and woman, showing human anatomy. They included pictures of various animals, plants, and landscapes from around the world. They wanted any potential finder to understand not just what we looked like, but how we lived, what we valued, what made us human. The musical selections were equally carefully chosen, ranging from Bach to Chuck Berry, from traditional music of various cultures to contemporary compositions. Each piece was selected to showcase the incredible diversity and creativity of human culture. The Grand Tour and the Pale Blue Dot, the journey that would normally take 40 years with a regular rocket, was made possible in just 12 years because of this Grand Tour. Voyager 2 is the only spacecraft in history that has completed this entire tour. Let's go to our first stop. Stop number 1, the King Jupiter. First, in March 1979, Voyager reached Jupiter. Until then, we thought Jupiter was just a big ball of gas. But Voyager showed us that Jupiter is a violent and chaotic world. Voyager revealed to us that Jupiter also has rings. Yes, just like Saturn, but these are very thin and faint. And that famous Great Red Spot, Voyager's close-up photos revealed that it was a massive anticyclone storm, so large that 3 Earths could fit inside it. This storm has been raging for at least 400 years, possibly much longer. The winds in the storm reached speeds of up to 432 kilometers per hour. The sheer scale of this weather phenomenon is almost impossible to comprehend from an Earth-based perspective. But the real shock came from Jupiter's moons. The scientific community was shaken when they saw Io. We used to think that small moons in space were cold and dead. But active volcanoes were erupting on Io. Jupiter's massive gravity squeezes Io like a rubber ball, which generates so much heat inside that even rocks melt. This is the most volcanically active body in the solar system. The volcanoes on Io erupt with such force that they shoot material hundreds of kilometers into space. The surface of Io is constantly being renewed by this volcanic activity, making it one of the youngest surfaces in the solar system. The colors on Io are spectacular: yellows, oranges, reds, blacks, all created by different sulfur compounds deposited by the volcanic eruptions. Before Voyager, we had no idea such extreme geological activity could exist on a moon. And then there was Europa. Its surface was completely smooth and made of cracked ice. Voyager's data hinted that beneath this thick layer of ice, there could be an ocean of liquid water. An ocean that might even harbor life. This discovery is still one of the greatest hope in space exploration today. The implications of a liquid water ocean beneath Europa's ice shell are profound. Where there is liquid water, there is the potential for life as we know it. The cracks and ridges on Europa's surface suggest that the ice shell is constantly shifting and breaking, possibly due to tidal forces from Jupiter's gravity. This means that the ocean beneath might be in contact with the rocky core of the moon, allowing for chemical exchanges that could support life. Future missions are being planned specifically to explore Europa further, to drill through the ice and sample the ocean beneath. If life exists on Europa, it would be one of the most significant discoveries in human history, proving that life can exist beyond Earth. Voyager also discovered several other moons of Jupiter that were previously unknown. Each moon told a different story about the formation and evolution of the Jovian system. Ganymede, the largest moon in the solar system, showed evidence of both old and young surfaces, suggesting a complex geological history. Callisto, heavily cratered and ancient, appeared to be a frozen record of the early solar system. Each of these discoveries added layers to our understanding of how planetary systems form and evolve. The data collected by Voyager at Jupiter alone could fill libraries, and scientists are still analyzing it decades later, still making new discoveries from those precious observations. Let's now move to our second stop, the jewel of the solar system, Saturn. Before Voyager reached Saturn, we thought Saturn had 3 or 4 thick rings. But when Voyager arrived there, it saw thousands of rings. These rings were not solid. They were made of billions of particles of ice and rock. Some of these were as small as grains of sand, and some were as big as houses. Voyager discovered shepherd moons there. These small moons use gravity to keep the ring particles in line. The complexity of Saturn's ring system is mind-boggling. Each ring has its own characteristics, its own density, its own composition. Some rings are bright and reflective, made primarily of water ice. Others are darker, containing more rock and dust. The rings are incredibly thin compared to their diameter, in some places only tens of meters thick, while extending hundreds of thousands of kilometers. The shepherd moons that Voyager discovered play a crucial role in maintaining the structure of the rings. These small moons orbit within or near the rings, and their gravitational influence creates gaps and keeps certain rings confined. Without these shepherd moons, the rings would gradually spread out and dissipate. This was a completely unexpected discovery that revolutionized our understanding of how ring systems work. The interaction between the moons and the ring particles is a delicate gravitational dance that has been ongoing for billions of years. Scientists have used computer simulations to model these interactions, and the complexity is staggering. Each particle in the rings is essentially a tiny moon, orbiting Saturn according to Kepler's laws, but also influenced by the gravity of other particles and nearby moons. Asterisk friends, after this, we had to make a sacrifice. Voyager 1 was not sent to the other planets after Saturn. Rather, scientists diverted it to look at Titan. But why? Because Titan is the only moon in the entire solar system that has its own dense atmosphere. Voyager saw that its atmosphere is denser than Earth's, and its entire sky is filled with orange-colored smoke. With Voyager's help, we saw that methane rain falls there and methane rivers flow there as well. This discovery was absolutely revolutionary. An atmosphere on a moon was completely unexpected. Titan's atmosphere is primarily nitrogen, just like Earth's, but it also contains significant amounts of methane and other organic compounds. The orange haze that covers Titan is created by complex chemical reactions in the upper atmosphere, where ultraviolet light from the sun breaks apart methane molecules, and the fragments recombine to form more complex organic molecules. The presence of liquid methane on Titan's surface was another stunning discovery. At Titan's frigid temperatures of minus 179 degrees Celsius, methane exists as a liquid. Playing the same role that water plays on Earth, there are methane lakes, methane rivers, methane rain, and even methane clouds. The methane cycle on Titan is analogous to the water cycle on Earth. Methane evaporates from the surface, forms clouds, rains back down, flows in rivers back to the lakes and seas, and the cycle continues. This makes Titan the only other body in the solar system besides Earth where we have observed liquid cycling on the surface. The implications for understanding planetary processes and even the potential for life are enormous. Voyager's observations of Titan were limited because it couldn't see through the thick atmosphere to the surface. But what it did see was enough to make Titan one of the highest priority targets for future exploration. Subsequent missions, particularly the Cassini spacecraft with its Huygens probe, would later provide much more detailed information about Titan, confirming and expanding on Voyager's initial discoveries. But it was Voyager that first revealed Titan's secrets and sparked the intense scientific interest in this remarkable moon. Asterisk. Let's now go to our third stop, the tilted giant Uranus. Voyager 1 was now heading out of the solar system, but Voyager 2's grand tour was still ongoing. In 1986, it reached Uranus. This planet turned out to be the strangest. All other planets spin like tops, but Uranus is lying on its side and rolling. Perhaps in the past, some Earth-sized object collided with it, which made it tilted. This extreme tilt gives Uranus the most extreme seasons in the solar system. Each pole gets 42 years of continuous sunlight followed by 42 years of complete darkness. Imagine living on a world where summer lasts for 4 decades and winter lasts for 4 decades. with no sunrise or sunset during those entire periods. Asterisk Voyager discovered a Frankenstein moon near Miranda. Miranda looks like someone forcibly joined different puzzle pieces together. Here is the deepest canyon in the solar system, which is 12 times deeper than the Grand Canyon. If you jump from there, it would take you 12 minutes to reach the bottom. The bizarre appearance of Miranda suggests a violent history. It's possible that Miranda was shattered by a massive impact in the past and then reassembled by gravity, which would explain why different regions of its surface look so completely different from each other. Some areas are heavily cratered and ancient, while others show evidence of more recent geological activity. The cliffs on Miranda, called Verona Rupes, are the tallest known cliffs in the solar system, with heights estimated at 20 kilometers or more. Asterisk. The low gravity on Miranda means that if you jumped off these cliffs, you would fall very slowly. In Earth gravity, you would hit the ground in just a few seconds from such a height. But on Miranda, the descent would take many minutes, giving you plenty of time to contemplate your decision. Of course, you would still hit the surface at a considerable speed, and the result would not be pleasant. But the experience would be unlike anything possible on Earth. Voyager's images of Miranda revealed a world that seemed to defy explanation. A moon that looked like it had been assembled from spare parts, each with its own distinct character and history. Asterisk Uranus itself proved to be a fascinating world. Its blue-green color comes from methane in its atmosphere, which absorbs red light and reflects blue and green. The planet has a system of thin, dark rings that were unknown before Voyager's visit. These rings are very different from Saturn's bright, icy rings. They are made of much darker material, possibly organic compounds that have been darkened by radiation over billions of years. Voyager also discovered several new moons of Uranus, bringing the total known count to 15 at that time. Each of these moons showed unique characteristics, from the heavily cratered surfaces of Umbriel and Oberon to the strange terrain of Ariel with its valleys and fault scarps. Asterisk, stop number 4, the last outpost, Neptune. Finally, after a 12-year-long journey in 1989, Voyager 2 reached the last planet. Despite being so far from the sun, Neptune was not cold and calm. The fastest winds in the solar system blow here at 2,000 kilometers per hour. This is faster than the speed of sound. Voyager saw the great dark spot there, a storm that could swallow the entire Earth. The existence of such powerful winds on Neptune was a complete mystery. The planet receives very little energy from the sun at such a great distance. So where does the energy come from to drive these incredible winds? Scientists believe that Neptune must have a significant internal heat source, energy left over from its formation that is still being released. This internal heat, combined with the planet's rotation and the effects of the sun's weak influence, creates the most dynamic atmosphere in the outer solar system. Asterisk. The great dark spot that Voyager observed was similar to Jupiter's spot, but it was not as long-lived. When the Hubble Space Telescope looked at Neptune a few years later, the great dark spot had disappeared, and a new dark spot had appeared in a different location. This suggests that Neptune's atmosphere is even more dynamic and changeable than Jupiter's. The storms on Neptune form and dissipate on timescales of just a few years, unlike Jupiter's Great Red Spot, which has persisted for centuries. The winds on Neptune are also notable for being retrograde in some regions, meaning they blow in the opposite direction to the planet's rotation. The mechanisms behind this are still not fully understood. Asterisk. And as it was leaving, Voyager saw one last miracle on Neptune's moon Triton. The space temperature was minus 235 degrees Celsius. Still, geysers were erupting on Triton. Nitrogen gas fountains were shooting 8 kilometers up from the ground. Even at the edge of darkness, the solar system is alive. Triton is one of the most fascinating objects in the solar system. It is the only large moon that orbits its planet in a retrograde direction, opposite to Neptune's rotation. This strongly suggests that Triton was not formed along with Neptune, but was captured by Neptune's gravity at some point in the past. Triton is likely a Kuiper belt object, similar to Pluto, that wandered too close to Neptune. and it was trapped in orbit. The geysers on Triton are powered by a surprising mechanism. Even though Triton is incredibly cold, the weak sunlight that reaches it is enough to warm the surface slightly during summer. This warmth penetrates through the transparent surface ice to a darker layer beneath, which absorbs the heat. The heat causes nitrogen ice beneath the surface to vaporize, building up pressure until it explosively erupts through cracks in the surface ice. The resulting geysers shoot nitrogen gas and dark particles high into Triton's thin atmosphere, where the particles are carried by winds and deposited in streaks across the surface. These dark streaks are clearly visible in Voyager's images of Triton. Triton's surface is also remarkable for its extreme youth. Despite being billions of years old, Triton's surface shows very few impact craters, indicating that geological processes have resurfaced it relatively recently in geological terms. The surface features include strange terrain that scientists have called cantaloupe terrain because it resembles the skin of a cantaloupe melon, with a pattern of pits and ridges unlike anything seen elsewhere in the solar system. There are also areas of smooth plains, areas covered with nitrogen frost, and regions with complex tectonic features. All of this activity on a moon in the outer reaches of the solar system was completely unexpected. After crossing Neptune, the Grand Tour officially ended. Voyager 2 showed us 2 new planets and 48 new moons. It erased the darkness of our ignorance forever. But the mission was not over yet. Now it was time for interstellar space. The journey through the outer solar system had been incredible, but in many ways, it was just the beginning. The Grand Tour had taken Voyager through the realm of the planets. But now it would venture into territory never before explored by human-made objects. Into the vast emptiness between the stars. Look at this photo. You can see brown-colored strips. That's the reflection of sunlight on the camera lens. And in between those strips, there is a small, faint pixel. That's us. That is us. On that 1 pixel is your home. Your friends and enemies are there. Every superstar, every scientist, everyone lives right there. In the face of the vastness of the universe, our entire history is equal to just a speck of dust. This photograph, known as the pale blue dot, was taken by Voyager 1 on February 14th, 1990, at the request of Carl Sagan. By that time, Voyager 1 had already passed beyond the orbit of Neptune and was heading out of the solar system. Sagan convinced NASA to turn Voyager's camera around one last time and take a picture of Earth from a distance of 6 billion kilometers. The image shows Earth as a tiny point of light, barely visible against the vast space. In Sagan's own words, that's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor, and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Friends, after this photo. Voyager's cameras were turned off forever to save as much power as possible. Now it is floating in space blind. This was a practical decision, but also a poignant one. Voyager had shown us wonders beyond imagination, but now its mission was changing. It was no longer about taking pictures or making close observations of planets. It was about venturing into interstellar space and reporting back what it found there. The instruments that remained active were those designed to measure the particles, fields and waves of space itself, not to take photographs. Interstellar space, the final frontier. The real story of Voyager didn't start when it went to Jupiter or Saturn. The real story started when it crossed the border where human imagination gives up. To understand this journey, we first need to understand the structure of the heliosphere. Our sun doesn't just give light, It continuously throws out solar wind. This is a storm of charged particles that emanates in every direction. As far as this wind blows, a bubble is formed. This bubble is called the heliosphere. Inside it, we are safe. Outside it is the interstellar medium, meaning the ocean between two stars, asterisk. The heliosphere is our protective cocoon in the hostile environment of interstellar space. The solar wind, a stream of charged particles constantly flowing from the sun, creates a bubble around our solar system. This bubble shields us from the majority of galactic cosmic rays, high-energy particles from distant supernova and other energetic events in the galaxy. Without this protection, life on Earth would be exposed to much higher levels of radiation, which would make the evolution of complex life much more difficult, if not impossible. The heliosphere extends far beyond the orbits of the planets, reaching out billions of kilometers into space. Asterisk to get out, Voyager had to break through three boundaries. Number one, the termination shock. Here, the speed of the solar wind changes from supersonic to subsonic. Voyager 1 crossed this in December 2004. This was the first major milestone in Voyager's journey into interstellar space. At the termination shock, the solar wind, which has been traveling at speeds of 400 to 800 kilometers per second, suddenly slows down to subsonic speeds. This happens because the solar wind is running into the pressure of the interstellar medium. The interstellar medium, though incredibly diffuse, still has some pressure, and as the solar wind expands outward from the sun, it eventually reaches a point where this pressure is strong enough to slow it down. The termination shock is not a smooth spherical boundary, but a turbulent, dynamic region where the solar wind is constantly buffeted by variations in the interstellar medium. Asterisk number 2, the heliosheath. This is the boundary's gray zone. Here, the solar wind starts to stop and turbulence is created. It took Voyager 8 years to cross this. The heliosheath is the region between the termination shock and the heliopause. In this region, the solar wind is no longer traveling outward in a smooth radial flow. Instead, it is turbulent and chaotic, mixing with particles from the interstellar medium. The magnetic field in the heliosheath is complex and variable. Voyager's instruments detected numerous magnetic structures in regions of enhanced particle density. This region is like a buffer zone between the solar domain and the interstellar domain, a transition zone where the influence of the sun gradually gives way to the influence of the galaxy. Asterisk. The journey through the heliosheath was full of surprises. Scientists had predicted what Voyager might find, but the reality was often different. The boundary was not where they expected it to be. The particle densities were different from predictions. The magnetic field structure was more complex. Each new measurement sent back by Voyager was eagerly analyzed, providing new insights into the nature of the heliosphere and its interaction with interstellar space. The data from this region alone has generated hundreds of scientific papers and will continue to be analyzed for decades to come. Asterisk number 3, the heliopause, the final border. This is the line where the sun's light completely stops and the interstellar wind coming from outside begins. August 25th, 2012 is one of the most important dates in history. On this day, Voyager 1 sensors sent some strange data. Suddenly, the cosmic rays coming from the sun disappeared, and the number of galactic cosmic rays coming from outside suddenly increased. Scientists were confused. Have we gone outside? To confirm this, they needed sound. The sound of plasma. There is no air in space, but plasma vibrates. When NASA converted Voyager's data into sound, they heard a screeching hum. That sound was confirming that the plasma around Voyager was no longer the hot plasma of the sun, but the cold and dense plasma of interstellar space. Asterisk. Voyager 1 had officially entered interstellar space. This was a moment of profound significance. For the first time in human history, a human-made object had left the protective bubble of our solar system and entered the realm between the stars. Voyager 2 crossed this same border in November 2018. Both are now in a zone where nothing has ever been before. The crossing of the heliopause was not a sudden event, but a gradual transition. Voyager 1's instruments showed that it actually crossed the boundary several times, moving back and forth as the boundary itself moved in response to variations in solar activity. Eventually, it made a final crossing and has remained in interstellar space ever since. What is interstellar space like? We often think that deep space is empty. This is wrong. Voyager has told us that interstellar space is not empty, but there's a dense soup of matter there. Scientists thought that as soon as Voyager went outside, the density would decrease. But the opposite happened. The density increased. Interstellar space is filled with the material of old, dead stars. This material is a mixture of gas, dust, and radiation, and Voyager is floating in this soup. The interstellar medium is not uniformly distributed. It has structure with regions of higher and lower density, regions of higher and lower temperature. Voyager is currently traveling through what is called the local interstellar cloud, a relatively dense region of the interstellar medium, asterisk, the wall of fire. Voyager detected that just outside the heliosphere, there is a plasma barrier like a wall of fire. The temperature here can be 300 to 500 degrees Celsius. Wait, if it's so hot, why didn't Voyager melt? Here, the temperature of the particles is very high, but the density is very low. This means the particles are hot, but they collide with Voyager so infrequently that Voyager doesn't feel the heat. In fact, Voyager is freezing from the cold. This is a common misconception about temperature in space. Temperature is a measure of the average kinetic energy of particles, but heat transfer depends on both temperature and the number of particle collisions. In the vacuum of space, even if individual particles are moving very fast and thus have a high temperature, there are so few of them that they cannot transfer significant heat to an object. Asterisk, right now, Voyager is being showered with cosmic rays. These are high-energy particles that have come from supernova blasts. The heliosphere protected us from these. Now Voyager is facing these rays without any shield. These rays can corrupt computer memory. That's why NASA has to use memory protection. Cosmic rays are one of the biggest challenges for spacecraft operating in interstellar space. These particles can penetrate the spacecraft's skin and interact with the electronics inside, causing what are known as single-event upsets. A cosmic ray can flip a bit in the computer's memory, changing a 0 to a 1 or vice versa. If this happens in a critical part of the software or in a critical command, it could cause the spacecraft to malfunction or even fail completely. Asterisk to protect against this. Voyager uses several strategies. It has redundant systems, so if one component fails, another can take over. It has error-correcting codes in its memory, which can detect and correct some types of errors. And it has watchdog timers that can reset the computer if it stops responding. Despite these protections, there have been several instances over the years where cosmic rays have caused temporary glitches in Voyager systems. Each time, the engineering team on Earth has worked carefully to diagnose the problem and send commands to fix it. A process that takes days because of the enormous distance and the resulting communication delay. Asterisk, the survival mode, power and communication. Friends, the biggest challenge of the interstellar journey is data, power, and communication lag. Currently, it takes about 23 hours for a signal from Voyager 1 to arrive. If NASA sends a command to turn on the camera, it will take 23 hours to go and 23 hours for confirmation to come back. A total lag of 2 days. Voyager cannot use solar power because the sun is now just a glowing star. It runs on an RTG nuclear battery. Every year, its power decreases by 4 watts. To stay alive, Voyager has to cannibalize itself. Scientists have turned off its heaters. Its instruments are now operating at minus 79 degrees Celsius. At this temperature, electronics should fail. But Voyager's hardware is beyond miraculous. Asterisk, the RTG, or radioisotope thermoelectric generator, is a remarkable piece of technology. It uses the heat from the radioactive decay of plutonium-238 to generate electricity. Unlike solar panels, which depend on sunlight, an RTG can generate power anywhere, even in the darkness of interstellar space. The plutonium-238 has a half-life of about 88 years, which means that every 88 years, half of it decays, and the heat output is reduced by half. Since Voyager was launched in 1977, a significant fraction of the plutonium has already decayed, which is why the power output has been steadily declining. Currently. Only 4 instruments are working on Voyager. First, the cosmic ray system. Second, the low energy charge particle instrument. Third, the magnetometer. And fourth, the plasma wave subsystem. NASA's plan is that by 2030, they will probably turn off the last instrument as well. After that, Voyager will just become a transmitter that will send not data, but just an I am alive signal. This will be a bittersweet moment. On one hand, it will mark the end of Voyager's active scientific mission, the end of its ability to send us new data about the universe. On the other hand, as long as the transmitter keeps working, we will know that our ambassador to the stars is still out there, still functioning, still carrying our message, eventually. Even the transmitter will run out of power. Current estimates suggest that this will happen sometime in the 2030s. After that, Voyager will go silent. It will still be traveling through space, still carrying the golden record, but it will no longer be in contact with Earth. It will become a ghost ship, drifting silently through the cosmos for billions of years. But even in silence, it will continue its mission because the golden record will still be there, still carrying its message, still waiting to be found. The future trajectory. Where is it going? People think Voyager has left the solar system. Technically, no. It has only left the magnetic border. The gravitational border is still remaining. Now, Voyager is continuously moving toward the Oort cloud. This is a shell of comets and ice around the solar system. It will take Voyager 300 years to reach the inner edge of the Oort cloud and 300 years to cross the Oort cloud and come out. Think about it, 300 years. By then, maybe humans will still be around or not. But Voyager will keep moving. The Oort cloud is a vast spherical shell of icy bodies that surrounds the solar system. It is the source of long-period comets, those comets that take hundreds or thousands of years to complete one orbit around the sun. The Oort cloud is so far away that sunlight takes weeks or months to reach it, and the sun appears as just a bright star from that distance. The Oort cloud extends from about 2,000 astronomical units from the sun to perhaps as far as 100,000 astronomical units or more. 1 astronomical unit is the distance from the Earth to the sun, about 150 million kilometers. So the Oort cloud extends from about 300 billion kilometers to perhaps 15 trillion kilometers from the sun. This is truly mind-boggling. Even though Voyager is traveling at about 17 kilometers per second relative to the sun, it will take 300 years just to reach the inner edge of this distant realm, and then another 300 years to cross through it and emerge on the other side. In 40,000 years. Voyager 1 will pass near a star called Gliese 445. This star is in the constellation Cumulus. Voyager will pass 1.6 light years away from it. Even at this closest approach, Voyager will still be incredibly far from the star, much farther than the distance between the sun and the Oort cloud. But on cosmic scales, this is considered a close encounter. In 296,000 years, Voyager 2 will pass near the star Sirius. This is the brightest star in our sky. After that, Voyager will orbit around the center of the Milky Way galaxy. It will take 225 million years to complete one orbit. This orbital period is known as a galactic year. In one galactic year, Voyager will travel once around the entire galaxy. Carried by the gravitational pull of the hundreds of billions of stars that make up the Milky Way. During this journey, Voyager will experience a wide variety of environments. Sometimes it will pass through dense molecular clouds, regions of space where new stars are forming. At other times, it will traverse the nearly empty voids between the spiral arms of the galaxy. It will pass near other stars, though almost never close enough for any significant gravitational interaction. It will be bathed in radiation from distant supernova, pulsars, and other energetic objects. Through it all, the golden record will remain, protected by its gold-plated cover, waiting for the day when someone, somewhere, might find it and learn about the civilization that sent it on this eternal journey. Asterisk to the science of detection. Will aliens be able to see it? Now we come to our main question. Suppose 40,000 years from now, or 1 million years from now, Voyager reaches near some alien system. Will they be able to see it? To find the answer to this, we have to use physics. There are 3 ways to find an object in space. First, light. Is it visible? Second, radio waves. Is it shouting? Third, heat. Is it warm? Let's understand each one by one. First, visual detection. Space is dark. Voyager has no light of its own. It only reflects the sun's light. But when it went far from the solar system, for it, the sun also became like a small star. Voyager is a 4-meter large object. For an alien telescope, finding a 4-meter stone in deep space is almost impossible. Let's think about this more carefully. Detecting an object visually in space depends on how much light it reflects and how far away it is. Voyager reflects very little light because it is small, and because the sun is now very far away and very dim from Voyager's perspective. From Earth, we can detect asteroids that are much larger than Voyager, but only because they are much closer and because they are illuminated by the sun from our perspective. An alien civilization, looking for Voyager, would face enormous challenges. They would need to know where to look, which direction in the sky. They would need a telescope powerful enough to detect the faint reflected light from a small object at an enormous distance. And they would need some reason to be looking in that particular direction in the first place. Thus the odds of a random visual detection are astronomically low. Even if an alien civilization had telescopes far more powerful than anything we have, the chances that they would happen to point one in exactly the right direction at exactly the right time to catch a glimpse of Voyager are infinitesimally small. Space is simply too big and Voyager is too small and too dim. Visual detection, while theoretically possible, is not a realistic scenario for Voyager being found. Second method, radio signals. Currently, Voyager is sending signals. The signals from its high-gain antenna are barely picked up by NASA's deep space network's large antennas. And the biggest problem is Voyager runs on RTG, radioisotope thermoelectric generator. Plutonium-238 gives heat, which creates electricity, and its plutonium is decaying. Between 2025 and 2030, Voyager's power will decrease so much that its instruments will shut down. And by 2036, its transmitter will completely shut down. After that, Voyager will go silent. A dead ship. Aliens will not get any signals. The radio signals from Voyager are already incredibly weak. The power output of the transmitter is only about 20 watts, less than a typical light bulb. By the time these signals reach Earth, they have spread out over such a large area that the power received is measured in femtowatts, quadrillionths of a watt. It's remarkable that we can detect them at all. This is only possible because of the enormous dish antennas of the Deep Space Network, which are designed to pick up the faintest whispers from distant spacecraft. An alien civilization would need similar or better technology to detect Voyager signals. And they would need to be listening at the right frequency and looking in the right direction at the right time. But even this small chance will disappear once Voyager's transmitter shuts down. After that, Voyager will be radio silent. It will emit no signals at all. There will be nothing for an alien civilization to detect, no matter how powerful their radio telescopes. The brief window during which Voyager is actively transmitting, from 1977 to around 2036, is cosmically insignificant. Those 60 years represent only the tiniest fraction of the billions of years that Voyager will spend drifting through space. The chances that an alien civilization will be listening at exactly the right time our vanishingly small. Third method is infrared. This is the best chance for aliens. Even if Voyager dies, the plutonium inside will still be slightly warm. If aliens have very advanced infrared telescopes, maybe they can spot this faint heat spot. But space is very big. Why would they look there where Voyager is? Unless they are specifically looking for us. Finding Voyager depends purely on luck. This is perhaps the most realistic detection scenario, but it still faces enormous challenges. The heat signature from Voyager is incredibly faint. The RTG produces less and less heat as time goes on, and that heat dissipates into the cold of space. By the time the plutonium has mostly decayed, which will take centuries, the temperature difference between Voyager and the surrounding space will be minimal. An alien civilization would need infrared detectors of extraordinary sensitivity to pick up such a faint heat signature at interstellar distances. They would also need to be surveying large areas of space, looking for anomalous heat sources. This is not impossible. We ourselves are developing increasingly sensitive infrared telescopes, and future space-based infrared observatories might be able to detect the heat from distant planets or even large spacecraft. But Voyager is much smaller than a planet, and it will be much colder. The challenge is immense. Furthermore, space is not actually empty. Even in the interstellar medium, there are occasional clouds of gas and dust. There are faint heat sources from various astrophysical processes. An alien civilization searching for heat signatures would have to sift through a lot of background noise to find Voyager. They would need to distinguish the faint heat from a small, cold object from all the other thermal sources in their field of view. This requires not just powerful telescopes, but also sophisticated data analysis and a reason to be looking. Why would they invest the resources to search for such faint signatures, unless they had some reason to believe there was something to find? The map and the danger. Did we make a mistake? Now let's discuss a scary scenario. Suppose aliens are advanced. They found Voyager. They played the record and decoded the map on the cover. On Voyager's cover, there is a diagram showing the position of 14 pulsars. Pulsars are stars that blink like lighthouses. Their blinking frequency is unique. For any advanced civilization, this map is a GPS coordinate. If they read this map, they can calculate exactly where this ship came from. This is where things get potentially concerning. The pulsar map on the gold record is actually quite clever. Pulsars are natural cosmic lighthouses, and each one has a unique rotation period and thus a unique pulse frequency. By measuring the frequencies of the pulsars shown on the map and comparing them to the pulsars they can observe, an alien civilization could triangulate the position of the sun and thus determine where Voyager came from. A map shows the position of the sun relative to 14 pulsars, and it gives the frequency of each pulsar in a binary notation using the hydrogen spin-flip transition as a unit of measurement. This is about as universal as you can get. Any scientifically advanced civilization should be able to understand this notation and use it to locate the sun. In principle, they could then send a message back to us, or even send a probe or a ship to visit us. This is where the dark forest theory comes in. Here comes the dark forest theory. This theory says that we should stay quiet in the universe because we don't know who is out there. It's possible that aliens are friendly, but it's also possible that they are hungry for resources. Stephen Hawking said that if aliens come to Earth, the result will be the same as when Columbus came to America. Maybe this is not good news for us humans. Through Voyager, we have told the universe our map, address, DNA, and weakness, everything. Was this our biggest mistake? The dark forest theory is based on a simple but chilling logic. If there are many civilizations in the universe and resources are limited, then those civilizations might be in competition with each other. A prudent civilization would hide its presence to avoid attracting the attention of potentially hostile neighbors. Broadcasting your location, as we have done with Voyager and with various radio messages sent into space, might be seen as dangerously naive. The theory gets its name from a thought experiment. Imagine a dark forest at night. You know there are other hunters in the forest, but you don't know if they are friendly or hostile. The safest strategy is to stay quiet and hidden. If you light a fire or make noise, you reveal your position and you become a target. Similarly, in the cosmic dark forest, a civilization that announces its presence might attract unwanted attention. Stephen Hawking and others have warned that we should be cautious about sending messages into space. We have no idea what kind of civilizations might be out there. They could be peaceful and curious, eager to make contact and share knowledge. Or they could be aggressive and expansionist, looking for resources or territory. Or they could be so alien in their thinking that we cannot predict how they would react to discovering us. The Golden Record contains a lot of information about Earth and humanity. It shows images of people, of our cities, of our planet from space. It includes sounds of nature and of human voices. It shows our DNA structure and gives our location in the galaxy. To a sufficiently advanced civilization, this is all the information they would need to find us. Is this a risk? Have we made a terrible mistake by sending out this interstellar message in a bottle? But Frank Drake and Carl Sagan had a different perspective. They argued that we should not be afraid. Voyager is so small and space is so big that the chances of it being found are almost zero. This is a bottle thrown into the ocean, but the ocean is so big that it may never reach any shore. The optimistic view is that the vastness of space is our protection. Even if there are hostile civilizations out there, the likelihood that they will ever find Voyager is infinitesimally small. The universe is unimaginably large. There are billions of stars in our galaxy alone, and hundreds of billions of galaxies in the observable universe. The volume of space is so enormous that even if there are millions of civilizations out there, they are likely separated by such vast distances that contact is extremely rare. Moreover, Voyager is not broadcasting a beacon. It is a small, silent object drifting through the void. Finding it would require an incredible stroke of luck or a deliberate search of a huge volume of space. Even if an alien civilization knows approximately where to look, finding Voyager would be like searching for a specific grain of sand on all the beaches of Earth. It's not impossible, but it's close to it. The Golden Record is more of a symbolic gesture than a realistic attempt at communication. It's humanity's way of saying, we exist, we are here, we tried to reach out. It's a message of hope and curiosity, a statement that we want to connect with others in the universe if they are out there. Asterisk, there's also another consideration. If a civilization is advanced enough to find Voyager and decode the Golden Record, they are probably already advanced enough to detect Earth by other means. Our planet has been leaking radio signals into space for over a century, ever since we started using radio technology. Any civilization with sufficiently sensitive radio, telescopes could detect these signals and locate Earth. Television broadcasts, radar signals, and other electromagnetic emissions have been radiating out from Earth at the speed of light, forming an expanding bubble that is now over 100 light years in radius. Any civilization within that bubble could potentially detect us. Golden Record or not, asterisk. So in a sense, Voyager doesn't significantly change our exposure. We are already visible to anyone who is looking for us. What Voyager does is to deliberately send a message to make an effort to communicate. It's a conscious decision to reach out rather than to hide. Whether this is wise or foolish, only time will tell. But it is a deeply human act, an expression of our curiosity, our hope, and our desire to connect with something beyond ourselves. Asterisk, 5 billion years later, the last evidence. Let's do a little time travel. In the future, about 5 billion years from now, our sun will start to swell due to fuel running out. It will gradually become a red giant. It will die and swallow Mercury, Venus, and perhaps our Earth as well. On that day, every trace of humanity will be erased. Our cities, our mountains, our internet, everything will be consumed in fire. There will be no evidence left in the universe that something called humans ever existed. Except one. Yes, the Voyager spacecraft. There's no air in space, no water, and no erosion. Voyager will look the same as it does today. The golden record attached to it will be shining. When Earth is finished, even then Voyager will be floating among the stars. This is our last will and testament. If aliens find it billions of years later, they won't find us. They will find our memories. They will think about what kind of strange and beautiful species humans were. They destroyed themselves, but before dying, they had the courage to touch the stars. Asterisk, this is perhaps the most poignant aspect of the Voyager mission. Long after humanity is gone, long after the Earth itself is gone, Voyager will still be out there, still carrying its message. The golden record is designed to last for billions of years. The gold plating will protect it from the harsh radiation and micrometeorites of space. The information encoded on it, the sounds, the images, the greetings in many languages will remain intact. In a very real sense, Voyager and the golden record are our most permanent legacy. The pyramids of Egypt, the Great Wall of China, all the monuments and works of art that humans have created will eventually be destroyed. The Earth itself will eventually be consumed by the dying sun, but Voyager will persist. Asterisk, if an alien civilization does find Voyager billions of years in the future, what will they make of it? They will find a carefully crafted message from a long-dead civilization. They will see images of the beings who created it, hear their voices, learn about their world. They will see that these beings understood mathematics and science, that they had music and art, that they felt emotions and formed relationships. They will learn that humanity reached out across the cosmos, hoping to make contact, hoping to be remembered. And in that moment of discovery, whenever it comes, humanity will live again, if only in the memory of whoever finds our message. Asterisk, so will aliens find Voyager? The possibility is almost zero. Mathematically, the emptiness of space will win. But almost zero is not zero. As long as Voyager is moving, there's hope. Voyager is the greatest proof of our curiosity. We knew we would be destroyed. We knew space was big. Still, we said hello. The universe is vast and indifferent, but we made our mark on it. We sent a part of ourselves out into the cosmos, not knowing if anyone would ever find it, but hoping that they might. This is the essence of the human spirit, to reach out, to explore, to communicate, to hope. Voyager embodies all of this. Asterisk, the mathematics of Voyager being found are daunting. Space is incomprehensibly large. The Milky Way galaxy alone is about 100,000 light years in diameter and contains billions of stars. Voyager, traveling at about 17 kilometers per second, covers about 1 light year every 18,000 years. In a billion years, it will have traveled about 55,000 light years, barely half the diameter of the galaxy. In that entire journey, the volume of space it passes through is still an infinitesimally small fraction of the total volume of the galaxy. The probability that it passes close enough to another star system for anyone there to detect it is extraordinarily low. Asterisk. But let's think about this differently. Let's imagine that the galaxy is teeming with life, that there are millions of civilizations out there. Let's imagine that some of them are actively searching for signs of other civilizations, using powerful telescopes and sophisticated detection methods. Let's imagine that they have the technology to detect faint objects in deep space, to pick up faint heat signatures or the glint of reflected starlight from a small metallic object. Even with all these optimistic assumptions, the chances of any one civilization finding Voyager are still vanishingly small. But if there are millions of civilizations, and if Voyager drifts through space for billions of years, passing countless star systems, then maybe, just maybe, the odds start to become non-zero. Asterisk. And here's another thought. Even if Voyager is never found by an alien civilization, it has already succeeded in its mission. The true value of Voyager is not whether it is found, but what it represents. It represents humanity's ability to dream, to imagine, to reach beyond our immediate circumstances. It represents our scientific and technological achievements. It represents our desire to explore and understand the universe. It represents our hope that we are not alone, that somewhere out there, there might be others like us. Others who look up at the stars and wonder. Asterisk, the Voyager mission inspired generations of scientists, engineers, and ordinary people. The images it sent back from Jupiter, Saturn, Uranus, and Neptune changed our understanding of the solar system forever. The pale blue dot photograph gave us a new perspective on our place in the cosmos, a humbling reminder of how small and fragile our world is. The golden record is a testament to human creativity and diversity, a carefully curated selection of the best of what humanity has to offer. Even if no alien ever hears it, we have heard it. We have seen ourselves reflected in that record, and we have thought about what it means to be human. Voyager has also pushed the boundaries of what is technologically possible. The fact that a spacecraft built with 1970s technology is still functioning after nearly 50 years, still sending back data from the edge of interstellar space, is a remarkable achievement. The engineers and scientists who designed Voyager built it to last, and it has exceeded all expectations. Every year that Voyager continues to operate is a victory, a triumph of human ingenuity and perseverance. The lessons learned from Voyager have been applied to countless other missions, helping us to explore the solar system and beyond. Asterisk and Voyager continues to teach us. Even now, in its silent cruise through interstellar space, it is sending back valuable scientific data. The measurements of the interstellar medium, the cosmic ray environment, the magnetic field structure, all of this information is helping us understand the space between the stars. This knowledge is crucial for planning future interstellar missions, for understanding how to protect spacecraft and astronauts from the hazards of deep space travel. Voyager is a pathfinder, showing us the way forward. Asterisk in the coming years. As Voyager's power continues to decline, we will have to make difficult decisions about which instruments to keep running and which to shut down. Each shutdown will be a small loss, a reduction in the amount of data we receive. But it is necessary to extend Voyager's life as long as possible. The goal is to keep the transmitter running as long as we can, to maintain contact with our distant emissary. Even when all the scientific instruments are off. Even when Voyager can no longer send us data about interstellar space. As long as we can still hear its signal, we will know that it is still there, still journeying onward. Asterisk. And then, one day, the signal will stop. Voyager's power will finally run out, and it will go silent. That will be a sad day, a day of mourning for all who have followed Voyager's journey. But it will also be a day to celebrate. We will celebrate the incredible journey that Voyager has made, the discoveries it has enabled, the inspiration it has provided. We will celebrate the fact that a part of humanity is out there among the stars, carrying our message, representing us in the cosmos. Asterisk, friends. If you ever feel lonely, remember that billions of kilometers away from Earth, in the darkness, a small piece of humanity is still moving forward. Voyager is our ambassador, our message in a bottle, our hope for connection. It carries with it the best of what we are, our science, our art, our music, our voices. It carries our dreams and our curiosity. And it carries our determination to reach out, to explore, to understand. Asterisk, the story of Voyager is ultimately a story about us. It's about what we can achieve when we work together, when we push the boundaries of what is possible, when we dare to dream big. It's about our place in the universe and our responsibility to that universe. It's about the fundamental human desire to explore, to discover, to make contact with the unknown. Voyager reminds us that we are a species of explorers, that we are curious, that we are brave, that we are capable of remarkable things. Asterisk, as we look to the future, as we plan new missions to explore the solar system and beyond, as we search for signs of life on other worlds, as we listen for signals from distant civilizations, we carry with us the spirit of Voyager. We carry with us the same curiosity, the same determination, the same hope. We continue to push outward, to learn, to grow, to explore. And somewhere out there, in the vast darkness between the stars, Voyager continues its journey, silent but enduring. A testament to the human spirit. Asterisk, the golden record will outlast us all. Long after the last human has died, long after the earth has been consumed by the dying sun, long after our entire civilization has crumbled to dust, the golden record will still be there, still carrying its message. And maybe, just maybe, billions of years from now, someone will find it. Someone will play it. Someone will hear the sounds of Earth, the voices of humanity, the music we created. Someone will see the images of our world, our cities, our faces. Someone will read the message we left, explaining who we were and where we came from. And in that moment, across the vast gulf of space and time, we will have made contact. We will have reached out and touched another mind, another civilization. We will have proven that we existed, that we mattered, that we tried. Asterisk, and even if that never happens, even if Voyager drifts through the void for eternity without ever being found, it doesn't matter, because Voyager has already fulfilled its purpose. It has shown us what we can do. It has given us knowledge, inspiration, and hope. It has reminded us that we are part of something larger than ourselves, part of a vast and ancient universe. It has taught us humility and wonder. It has made us dream of what might be possible, of what might be out there waiting to be discovered. Asterisk. So friends, whenever you look up at the night sky, whenever you see the stars shining in the darkness, remember Voyager. Remember that somewhere out there, beyond the farthest reaches of our solar system, beyond the protective bubble of the heliosphere, in the cold and empty expanse of interstellar space, a small spacecraft is still traveling. It carries no crew, no passengers, only a message from Earth. It moves silently through the darkness, a tiny speck of human achievement in the vast cosmic ocean. It is alone but not lost. It has a purpose, a mission that will continue for billions of years. It is our gift to the universe, our attempt to make ourselves known. Our declaration that we exist and that we care enough to try to reach out to others, asterisk, and as long as Voyager travels, as long as it carries the golden record with its sounds and images and greetings from Earth, there's hope. Hope that we are not alone, hope that someone out there will find it and understand it, hope that our message will be heard. This is the legacy of Voyager, not just the scientific discoveries it has made, not just the beautiful images it has sent back, but the spirit it represents. The spirit of exploration, of curiosity, of hope, of reaching out into the unknown with courage and determination. Asterisk, if you liked this video, please like it. Share it with your friends, and yes, don't forget to subscribe to our channel. I will meet you in the next video with another new mystery. Until then, keep looking at the stars. I will see you in the next one.